Okay. Okay. Good morning, everyone. Uh, I think I gave you some practice last Friday, and I think there are still some students who didn't get the result last Friday. Is there anyone who hasn't see the result for your midterm exam? I think only two, and maybe other students. So only two. Okay. 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 So later you can go to the office. Okay, I will continue for practicing. Uh, the first part is the U sub, and the other part is the its fundamental theory of calculus. Okay. So I hope these three integrations from the first one, tangent x, ln cosine x dx, the second one e to the square root of x over square root of x, and the third one x and 1 minus x with power of two thirds. Okay, so I think these three parts, I believe it's not too complicated. Okay, you can solve it these three with the substitution method. Um, and then there are number 3 and 4. This is also from fundamental theory of calculus. Let me start with the first part, okay, which is evaluating the integrations directly. So this one. So first is you have tangent x and then ln cosine x. Okay. First, what is your idea to solve this? Basically, it's substitution method. You need to substitute some parts of the function. But let's see if you can solve it. The idea, if you have the tangent, you can write in sine and cos. Okay. Okay. If this is sine over cos, and this is ln cosine, remember when you derive, okay, for example, if you derive the tangent x directly, you will get the secant squared. And secant squared will not getting you anywhere, right? If you derive the tangent x and you try to substitute the tangent x, you will not getting anywhere, right? But if you derive the ln cosine x, okay, ln, or using chain rule, ln become 1 over cos, right? And then the cos become minus sine, which is when you substitute the dx, it will cancel this part, right? Okay, get the idea? So if I have u is ln cosine x, okay, and du becomes 1 over cos x and then minus sine x dx. So dx will be negative cos x sine x du. Okay, and substituting this part into our original equations. So it will be integrations. It will have minus, and then u du, which is negative. This become half. U is ln. Or let me just remove this part. So negative and plus constant. Okay, I think okay, any substitution method. Okay, you need to think carefully how to substitute the equations. Okay? How you change the u. Okay, this u here. The idea is to remove all the x. Okay, if you want to substitute, and then integrations, and get this. Okay. The other is e squared of x squared of x dx. Okay, the next one is e. How you solve this one? Any idea? Oh yeah. Okay. Yeah. The first, I think, idea: substitute the square root of x, become u, and then you can cancel this, and then you get the only e and u. Okay. Or uh, we can think the function of e. Okay, if you have any functions with the e power with some functions, if you derive e, it will result in another e, right? If you have e to the x, it will be e to the x, right? If you have e to the 2x, it will be 2e to the 2x, right? The chain rule. So, for example, if you have f of x, if f of x is e to the square root of x, okay, the first derivative will be e to the square root of x multiply with the, oh, let me write the complete steps. the chain rule. So it becomes e to square x. It will be 1 over 2 square root of x, right? So this form is similar with this, right? So we can just multiply by 2. It becomes our original functions, right? So let me multiply by 2. So our functions is actually 2e squared of x plus c. Okay. You can also use the substitutions. You can substitute the square root of x and still you get the same results. Okay. Yeah. Oh yeah, by the way, do you bring your midterm exam? I think we need to collect back all the midterm. So if you bring now, can you collect? I forgot to mention last Friday. Okay, thank you. Yeah, just yeah, put it. Okay, now the third one is x, 1 minus x, 2/3. Okay, basically, anytime you see you have x, okay, it's the first degree. This is also the first degree x. You can have this 1 minus x inside the square root, any power, maybe 2/3, 1/4, any square root of power. The idea is still the same as we did last Friday. We just make it 1 minus x equal to u. Okay. So substitute the 1 minus x, okay, and you will get the u is 1 minus x. So du is minus dx. So the idea is you have x and then u and then 2/3. You still have x, and this x will be substituted by x is 1 minus u. So 1 minus u and then u 2/3. Okay, now let's solve this. Okay, and I believe you can solve this integration easily. Okay, I will skip this part. Okay, I will move to number 2. So this is number 1. Number 2 is you have x sine pi x integration 0 x squared f t dt. Okay, I will give you some time to think and maybe write the other parts. Okay, so I give this u 2/3 5/3. Please solve this. Okay, I think it's not too difficult. Right? Just make the reverse of the power rule. Okay. Okay. Number 2, you have x sine pi x 0 x squared f t dt. Okay. All the problems related to uh, the fundamental theory of calculus is the idea is to remove these integrations with differentiations. Most of the problems in the fundamental theory of calculus is you have these expressions and you need to differentiate these expressions. To differentiate this, first, let me write the basic one. If you have integrations, let's say 0 or maybe a, any constant, to x, this is ft dt. So if you differentiate this, it will going back to original equations. Okay? What if this is from a to 2x? What will happen here? Yeah, 2f of x. So this is 2f of x. So that is coming from, so let me write the whole, okay. So the idea is the first case without any constant, it's just x. You get the f of x. And the idea, if you have differentiations for this whole integrations, meaning you differentiate this become f of x, and you need to multiply this these variables here. You need to also differentiate if this is functions of x. Okay. Okay, you need to grasp the basic concept for the fundamental theory of calculus. So if you have any the endpoint is any functions of x, okay, any functions of x, meaning you need to include this chain rule inside the results. Okay. Okay, got it? Got it? So if you have this question is x squared, the question having the x squared, meaning you will need to, so this ft dt become fx multiplied by ddx of x squared, which means the 2x. Okay, so this become 2x f of x. Okay, get it? So ddx, let me write the ddx first. So the left part is just a regular product rule, and then solve this based on what we've done here. So this becomes 2x f of x, and this will be the product rule. Okay. So this will be sine pi x plus x let me write the constant first. So pi x cos pi x, right? The chain rule for the sine pi x is cos pi x multiply with the inside is pi, and then multiply with the x. And then it's equal f, this is x squared, and then 2x. Okay. The question is f4. Okay. So f4 is when x is 2, right? And then you can solve the whole equation. So you need to just plug in 2 here, 2, 2, and this become f4. This is 4. So f4 is 1 over 4. This is 0. Sine 2 pi is 0. And this will be 2 pi. And then cos 0 is 1. So this 2 pi. So it's pi over 2. Okay. Okay. I hope you remember the concept for the fundamental theory of calculus. Okay. So I think you still need this theorem next semester. Yeah, I think. Okay. So basically, you have function of x here. Put all x inside the t, and then chain rule the functions. Multiply by 2x. Okay. I think I can go on for number 3, and then number 4 I will skip for now. I will move to another section first for chapter 6, and maybe we can review sometimes maybe next week. Okay. Actually, I'm planning to have the chapter 5 quiz maybe next, not this week, but maybe next Friday, around Friday. Or do you want next Monday? No, no, no. Okay. So chapter 5 will be Riemann sum, the fundamental theory of calculus, the substitution method. Yeah. Which one? Any constant, same. Yeah, the same. Any constant is the same. It will not affecting. Yeah, only the endpoint. I think you can take a look the notes that's proving that whenever you have any a here, the A will cancel each other when you separate the function become three integrations, and it will resulting only the endpoint at the end of the equations. Okay. So maybe you have 3 here, 4, doesn't matter. Doesn't matter. Oh, that will be different. If this is x and this is x squared, then you need to minus. Okay, so you need to put uh, the x squared to x. If this is x, then you have minus fx. Let me write. Let me write for you. Okay, let me write for you. So if you have, for example, this is x, and this is x squared. This is f dt. If you have derivative, then this will be, the first one will be f x squared, and then 2x, and then minus fx. Okay. This is also fundamental theory of calculus. I think uh, the first part is stating if you have this. Uh, let me write. So this is one. Okay. Number two, if you have a, b, you also have this, right? So when you have the x, then you have the minus fx. Or if you want, okay, if you want, if x is defined in some interval, maybe you can use the 0 or any constant to separate x and x squared, maybe. And you will see that because x is at the bottom, when you move to the top, you will need to multiply by negative, right? So that's why it's negative. Okay, that's also you can think of. You can separate and then make these separations. But I think it's just the last endpoint here. The first endpoint will be this minus part. Okay. 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 Any other questions? Any questions? Okay. Let me go to number 3, and after that we can move to another section in our chapter 6. So number 3, if the question is the functions is okay, this is the questions. Do you still need to see the last part? You still need to see this part? Okay, if not, then let's continue number 3. So now you have um, f of x and g of y. F of x integrations from 0 to sine x. So the function is now the sine x at the endpoint, and also the inside is not f of t. It's directly the functions. Okay? Usually it's the function of t, right? And this is directly the functions. Okay, the t functions, and this is fx dx. And the question is uh, the second derivative of g when you plug in y equal pi over 6. So let me give you another couple minutes to think and solve the problem. Of course, the whole idea here is to remove this integral. To remove the integral. Okay. To remove the integral, you need to differentiate, right? You put the ddx at the front, and you will cancel the integrations. But you need to solve the inside functions. And also see the relation between f and g. Okay? F, this is the function of t, but g is function of x. So whatever happened in here, it will affecting this one, right? So think, if you try to differentiate the g second in the second derivative, so maybe the first time you differentiate, it's becoming only f y, right? If you first derivative. Second derivative, fy prime, right? Fy prime is this. Differentiate, become f prime x. Get it? Get the connections? No? Try to write the equation. Okay. Find the relation between f and g. So let me write f of x. Okay, let's differentiate this. It's become the f prime x, right? And this become square root of 1 plus sine squared x. And don't forget you have the chain rule for the sine x. Write down the chain rule. So the f prime x is cos x. Okay, we get the f prime now. We get the f prime. Now we see the g. Let me write in the another page. So g of y is 3 to y f of x dx. And try to find the first derivative. This become g prime y. This become fy, right? So g double prime y is f prime y, right? And g double prime pi over x, pi over 6 is also same as f prime pi over 6. Okay. So f prime pi over 6 is square root of 1 plus sine squared of pi over 6 multiplied with cos pi over 6. So this is 1 plus sine 30 is half, so it's 1 over 4. This is square root of 3. Yeah, square root of 15 over 4. Okay. For number 4, it's a little bit long, so I will skip it for now. And I need to move to the chapter 6, area between curves. Okay, any questions from this part? So again, the integrations part in calculus is I think it's more difficult than the only derivative part, because in integration you need to also think the derivative. So uh, the content will be actually much more than the derivative part. Okay. Okay. Let let let's see the chapter 6. So chapter 6. This is the area between curves. Okay. Okay, let's say uh, this is g of x, and this is f of x. Okay. If we just consider the f of x, the area under the curve, we will only have from this curve until this x-axis, this is the height, right? If we have two curves, like the f and g, okay, the difference is if we want to evaluate the area here between f and g, meaning the height of this rectangle will be this f of x minus the g of x, the difference between f and g, between the height, okay? And similar with our Riemann sum, we plus all the rectangle, and then we define that sum as our integrations. Okay, so if we have sum of n and multiply by the delta, let's say this is the delta, and this is the height. So the area will be limit as n approach infinity, and we can define this as area is the region uh, bounded by the curve y equal f of x, y equal g of x, and if we have some constant from a to b, we can also take that a b into our boundary, and x equal a, x equal b. If f and g continuous function and f of x is greater than g, for x is at the AB interval, then the area will be AB fx. Okay. So basically with this basic, we can compute any area. If you have any curves and you need to find the area between the curves, you can do it based on these basic definitions. The trick part later is to determine the AB, okay, and to determine which functions you need to use. Okay, you can use dx, also dy. I will explain later. You can also use dy. Okay. Any questions? No, I think it's not too complicated. Okay, let me give you an easy example. I think I also gave in the PDF file. So find area bounded by y equal x squared plus 1 and by y to the equal x. And bounded also by x equal 0 and x equal 1. Okay, I will write some notes, okay? For area between curves, you need to at least draw the illustration. Determine the area determine the integration. So usually in area between curves, you'll be receiving some information about the curves, usually polynomial or trigonometry or exponential maybe. And you need to at least have in your mind how to draw the graphs, okay? And that's really important. If you draw wrong graphs, you will be getting wrong answers, or maybe you will not getting any clue on how to solve the questions. Okay, I gave you the examples. I think it's not too difficult, right? Yx squared plus 1, this yx squared plus 1 is just x squared, move 1 point up, right? So maybe if this is 1, 1, 2, 2. Let me draw the y equal x first. Yeah, let's say that's y equal x. And the other part here. This is 0, this is 1. So you will get the area is here. I will illustrate the rectangle. So this is the x. This is the difference, the height. So area will be, let me write A, B, the basic definitions. So A will be integration from 0 to 1, x squared plus 1, okay? This is x squared plus 1. And then minus x and the x. Integrate. And you get 5/6. Okay. Try the other example. Find area enclosed by y equal x squared and y equal 2x minus x squared. Okay, try number 2. It's x squared and 2x minus x squared. Because I think you need to get used to drawing some simple polynomial. Okay, so I think several students they cannot draw this 2x minus x squared. Okay, Please practice this, okay? To remember, this is minus x squared. This is x squared. X squared like this, right? So if you have minus, it should be like this, okay? And then you have 2x here. And actually, you can just try with several x, 0, 1, 2, and you can see the polynomial will make a shape. Okay. Let's say this is our x squared. Should be yeah, should be like that. This is y 2x minus x squared. So the area is inside here. If I draw this as dx, and this is the height, then you can see the area is between the red curve and the blue, right? If it's happening on any functions, I think because this is simple functions, you can determine this point, right? This is 0, this is 1, from just putting on the point, and then you can see the scale of this is 0, this is 1. But if you cannot really determine what it is, then you need to solve the intersections. Solve the intersections. Okay. To solve the intersections, based on these two curves, then x squared is equal to x minus x squared, right? So 2x squared minus 2x is 0. So you will have 2x, x minus 1. So x is 0 and x is 1, which is true based on our drawing here. So this is 1, 1. This is 0, 0. Okay. And then our area will be from 0 to 1. So this will be 2x minus 2x squared. So 2 so this will be half x squared minus 1/3 x cubed. So half minus 1/3 is 3, 6. 1/6 to 1/3. Okay, so I gave you the very basic how to find the area between curves. Okay, later, maybe next Friday, I will give you more practice. Well, let's just keep on to basic examples first. Okay, so you get the idea on how to calculating the area between curves, which is you just need to uh, basically, if you have this, okay, if you have the curve here and you have the curve, the blue one and the red one, the method is actually saying the first functions here on the top minus the functions on the bottom. Okay. I will give you some exceptions based on the shape of the area, but later. But the idea is just this, the functions on the top minus the functions on the bottom. Okay, and then just integrate and find the interval. Okay, any questions so far? Okay, I think it's actually it's not too the basic is not too difficult. Okay. Okay, let me draw the okay. I will have this. The red one is the f of x. The blue one is g of x. Now we have uh, three area, right, in between the curves. Okay. We can still writing the area from A to B as the function on the top minus the function on the bottom, but it's an absolute value. We can write this. And later, we need to define the f and g. So A1, the red one minus the blue one, right? So f minus g from A to something point here, some point, okay? And then A2, g minus f from this point until this. Let me maybe make another point. Maybe this is C and this is D. And A3 is back to the f minus g. So f of x minus g of x, we can have this as fx minus gx and gx minus fx. This is if and this is g greater than f. Okay. And for example, you can write A to C. So fx minus gx dx, and then plus C to D gx minus f of x, and plus D to B. Okay. So you may have the area is not always like one area. So if the question is like, for example, sine and cos is maybe like the graph, right? it will have more than one area in between the curves, right? So you need to plus all that integrations, and you need to input the interval, the intersection between the curves. Okay. Yeah, let's see the sine and cos. Okay. Let's say this is 1, this is pi over 2. So sine will be like this. Yeah, let's say this is sine. And cosine will be like this. Okay, because we only consider from 0 to this pi over 2. So I think I draw not too correct. Should be symmetrical. Let me draw one more time. Okay, maybe that's more likely. So you have A1 and A2, right? And this is pi over 4. So you need to compute, okay, from 0 to pi over 4, A1, or let me write this as cos x minus sine x dx. This is A1. And A2 will be integration. Wait, wrong. And the total area will be A1 plus A2, right? Okay, you can solve this, find the integrations, find the results. But, okay, but you know the sine and cosine is actually the same curve, just shifting pi over 2 to the right side, right? The difference between the phase difference between the sine and cosine is just pi over 2, right? So I can say that A1 and A2 is actually equal. The size is equal, okay? So you can actually just calculating A1 multiplied by 2. That's also fine because it's symmetrical, okay? Okay, so anytime you get the integrations and you think that the other part of the area will be symmetrical, then you need just to find the half of that area and multiply by 2. It's much more easier than computing all this and put all the endpoint and calculating one by one. But that's also fine if you want to. But rather than that, you can just compute 0 to pi over 4 and then multiply by 2. Okay. So I'll write here. You can also so A is to A1 because symmetry. So I will give you all the basic steps for the area between curves, and after that we will get some practice. Okay. So this is symmetrical. You can use the symmetry in the integrations. Okay. The next part is, let me draw the graph. Let's say this is C, this is D. Okay, if we have these functions, so let's say this is x equal gy, and this is x equal fy. Now we have f of y and g of y. So we have functions in y, right? If we see in x, the previous one, remember that I told you before, the functions on the top minus the function on the bottom, right? Now, what will happen? First, the easy one is you can just look at here. Oh, the top and bottom, right? Okay, get the idea? Or you can just saying that the function on the right minus the function on the left. That's also fine. But usually, when I did some calculation, usually I just like I think it's faster, and or just rotating the graphs. Okay? Maybe when you draw in the exam, you need just to rotate your paper, rotate your paper, and you see, okay, this you can define the rectangle. Okay, so define the rectangle. So the rectangle becomes dy. Okay, so okay, so whenever you have this kind of situations and you want to calculate dy, then if you have, for example, maybe you have functions in y equals some x squared, x cubed, something like that, you need to rewrite the functions and change into y. So if you have y equal x squared, so x should be equal square root of y, and use the square root of y instead of the x1. Okay, so I'll write the area will be, so area will be CD. Let me write this as XR XL, meaning right and left. XR XL dy. Or in this case is g of y. It should be f minus g, but yeah, I think that's also fine. As long as you understand the concept, okay? So G minus F based on our definitions up there. Okay, let me give you one example for this case. So find area enclosed by y equal x minus 1, y squared equal to x plus 6. Yeah, I think this is just 2. Okay, and then first thing you need to do is you need to at least draw what kind of graphs you have, and then finding the intersection point, your integral interval, the interval. Okay. Okay, first I'll try to draw first. Try to draw first. I need to draw correctly. If you still cannot draw correctly, I'm suggesting to look at some websites or some notes about the functions, how to draw the functions. Now you have y squared, right, instead of x squared. If you have x squared like this, then y squared will be, you need to just switch y to x. Okay. And I hope you can find the intersection point also.